Hello everyone. We have started Petroleum Engineering series. The first 20 sections have already been covered. If you have not watched the previous video, we would highly recommend you to watch it. However, the sections taught in this video do not rely on any background knowledge. Also, if you desire, then you can jump over the other sections. The timelines are available in the description of this video. Section 21. Understanding the different types of petroleum contracts and agreements. The petroleum industry involves many complex agreements and contracts between companies, governments, and other stakeholders. Understanding the different types of petroleum contracts and agreements is crucial to navigating the industry. This guide will provide an overview of the basics of petroleum contracts and agreements. 1. Production sharing contracts, PSCs. Production sharing contracts are commonly used by governments to encourage foreign companies to invest in oil and gas exploration and production. Under a PSC, a company is granted the right to explore and produce oil and gas in a particular area in exchange for sharing a portion of the production with the government. The government usually retains ownership of the resources. 2. Joint Operating Agreements, JOAs. Joint operating agreements are used by companies that want to work together to explore and produce oil and gas. A JOA is a contractual agreement between two or more companies to pool their resources and share the risks and benefits of exploration and production. The agreement outlines the responsibilities and liabilities of each party. 3. Concession agreements. Concession agreements are used by governments to grant oil and gas exploration and production rights to companies. Under a concession agreement, the company is granted the exclusive right to explore and produce oil and gas in a particular area. The company pays the government a royalty or other fees for the rights to explore and produce. 4. Service contracts. Service contracts are used by companies that provide services to the petroleum industry. Under a service contract, the company provides a service, such as drilling or seismic surveys, to an oil and gas exploration or production company. The service company is paid a fee for its services, but does not have an ownership interest in the oil and gas produced. 5. Farm-out agreements. Farm-out agreements are used by exploration and production companies to acquire the rights to explore and produce in a particular area. Under a farm-out agreement, the company with the exploration and production rights, the farmer, transfers some or all of those rights to another company, the farmee. The farmee usually pays the farmer for the rights. In conclusion, understanding the different types of petroleum contracts and agreements is critical to navigating the industry. Production sharing contracts, joint operating agreements, concession agreements, service contracts, and farm-out agreements are just a few examples of the types of agreements used in the industry. Each agreement has its unique features, and it is essential to consult with legal and financial experts to ensure that the terms and conditions of the agreement are understood and that the agreement meets the goals and objectives of all parties involved. Section 22. An introduction to the principles of petroleum geomechanics and rock mechanics. Petroleum geomechanics is a field of study that is crucial to the petroleum industry. It involves the study of the mechanical properties of rocks and their behavior under stress and pressure. Understanding the principles of petroleum geomechanics is critical in designing drilling and production operations, evaluating the integrity of wells, and ensuring safe and efficient operations. This article provides an introduction to the principles of petroleum geomechanics and rock mechanics, including the different types of rocks and their properties, the stresses that affect rocks, and the different methods used to measure rock properties. Types of rocks and their properties. Rocks can be classified into three main categories: sedimentary, igneous, and metamorphic. Sedimentary rocks are formed from the accumulation of sediment, such as sand or mud, that is compacted and cemented over time. They make up the majority of the rocks found on the Earth's surface and are the primary source of hydrocarbons. Igneous rocks are formed from the solidification of molten magma or lava. They are less common than sedimentary rocks but can be found in areas with volcanic activity. Metamorphic rocks are formed from the alteration of pre-existing rocks due to heat and pressure. They are often found in areas where tectonic activity has occurred. The mechanical properties of rocks depend on various factors, such as their mineral composition, porosity, and permeability. Porosity refers to the amount of space between grains in the rock, while permeability refers to the ability of fluids to flow through the rock. Stresses affecting rocks. The behavior of rocks under stress is another essential component of petroleum geomechanics. Rocks can be subjected to three types of stress: compressive, tensile, and shear stress. Compressive stress occurs when rocks are pushed together, tensile stress when they are pulled apart, and shear stress when they are pushed in opposite directions. The application of stress to rocks can result in various responses, such as deformation, failure, or cracking. Understanding the response of rocks to stress is crucial in designing drilling and production operations. Measuring rock properties. Various methods are used to measure the mechanical properties of rocks, such as porosity, permeability, and compressive strength. One of the most common methods is core analysis, where rock samples are taken from the subsurface and analyzed in a laboratory. Other methods include well logging, where measurements are taken while drilling, and seismic imaging, where sound waves are sent through the subsurface to measure the properties of the rocks. Conclusion. In conclusion, understanding the principles of petroleum geomechanics and rock mechanics is critical in the petroleum industry. The different types of rocks and their properties, the stresses affecting rocks, and the various methods used to measure rock properties are essential to designing safe and efficient drilling and production operations. By applying these principles, engineers can design and operate oil and gas wells while minimizing the risk of well failure or environmental damage. Section 23. A Guide to the Basics of Reservoir Engineering and Management. Reservoir engineering is a crucial aspect of petroleum engineering that involves the application of scientific principles and methods to the exploration and production of hydrocarbons from subsurface reservoirs. It focuses on the design and optimization of production operations to maximize the recovery of oil and gas reserves while minimizing costs and environmental impact. This guide provides an overview of the basics of reservoir engineering and management, including the key concepts and techniques used in the industry. Reservoir characteristics and properties. The first step in reservoir engineering is to understand the characteristics and properties of the subsurface reservoir. This includes the reservoir's size, shape, depth, porosity, permeability, fluid saturation, and pressure. This information is obtained through geological and geophysical surveys, well logs, and reservoir models. Reservoir simulation and modeling. Reservoir simulation and modeling are used to predict the behavior of the reservoir and optimize production operations. This involves creating a computer model of the reservoir using data on its characteristics and properties. The model is then used to simulate the flow of fluids through the reservoir and predict the performance of various production strategies. Reservoir management. Reservoir management involves the ongoing monitoring and optimization of production operations. This includes well testing and data analysis to track the reservoir's performance and identify opportunities for improvement. Reservoir management also involves the design and implementation of enhanced oil recovery techniques, such as water flooding, gas injection, or chemical treatments, to improve recovery rates. Production forecasting. Production forecasting is the process of predicting the future production of a reservoir based on its current and historical performance. This information is critical for making informed decisions about investment and production strategies. Economic analysis. Reservoir engineering also involves economic analysis, which considers the costs and benefits of various production strategies. This includes calculating the net present value of the project, estimating the expected return on investment, and determining the optimal production rate and time frame. Conclusion. Reservoir engineering is a critical component of the petroleum industry that involves a variety of concepts and techniques. It is essential for maximizing the recovery of oil and gas reserves, minimizing costs, and ensuring that operations are environmentally responsible. By understanding the basics of reservoir engineering and management, engineers can make informed decisions and optimize production operations. Section 24. Understanding the different types of well stimulation and completion techniques. In the world of petroleum engineering, well stimulation and completion techniques are crucial for extracting oil and gas from the reservoir. These techniques help in enhancing the productivity of a well and optimizing the flow of oil and gas. Here, we will discuss the different types of well stimulation and completion techniques. Hydraulic fracturing. Hydraulic fracturing, also known as fracking, is a process in which water, sand, and chemicals are injected at high pressure into the rock formation to create small fractures. This process is used to extract oil and gas from shale rock formations. The sand particles help to keep the fractures open and allow the oil and gas to flow. Acidizing. Acidizing is a process in which acid is injected into the well to dissolve the minerals and create channels for the oil and gas to flow. Acidizing can be done using hydrochloric acid or other chemicals depending on the type of rock formation. Perforation. Perforation is a process in which small holes are created in the well casing and into the rock formation. This process is done using a perforating gun, and it allows the oil and gas to flow into the wellbore. Gravel packing. Gravel packing is a process in which small grains of sand or gravel are packed around the well casing to prevent the formation from collapsing into the wellbore. This process helps to keep the fractures open and allows the oil and gas to flow. Sand control. Sand control is a process used to prevent sand from entering the wellbore. This process is used in sandstone formations where the sand can erode and clog the wellbore. Sand control can be achieved using screens or gravel packing. Multi-stage fracturing. Multi-stage fracturing is a process in which multiple fractures are created in a single wellbore. This process is used to increase the production of oil and gas from the well. Intelligent completions. Intelligent completions use downhole sensors and control systems to optimize the flow of oil and gas from the well. These systems can be used to control the flow rate and pressure of the well. In conclusion, the different types of well stimulation and completion techniques play a crucial role in enhancing the productivity of a well and optimizing the flow of oil and gas. The selection of the technique depends on the type of reservoir and rock formation. A thorough understanding of these techniques is essential for a successful petroleum engineering career. Section 25. A Guide to the Basics of Petroleum Reserves Classification and Estimation. Petroleum reserves classification and estimation is an important concept in the oil and gas industry. The process is crucial to understanding how much oil and gas is in a particular reservoir, and it helps companies plan their exploration and production activities. In this guide, we will take a look at the basics of petroleum reserves classification and estimation. Petroleum reserves classification and estimation is the process of determining the amount of oil and gas in a particular reservoir. The process involves geological and engineering analyses to estimate the amount of oil and gas that can be extracted from the reservoir. The process is essential for oil and gas companies to make informed decisions on exploration and production activities. Classification of petroleum reserves. Petroleum reserves are classified based on the level of certainty in the estimates. There are three main classifications of petroleum reserves: proved, probable, and possible reserves. 1. Proved reserves are the estimated quantities of oil and gas that can be extracted with reasonable certainty. Proved reserves are the most reliable estimate and are based on geological and engineering data. 2. Probable reserves are the estimated quantities of oil and gas that are less certain than proved reserves. Probable reserves are based on data that is less reliable than proved reserves and require additional analysis to confirm. 3. Possible reserves are the estimated quantities of oil and gas that are less certain than probable reserves. Possible reserves are based on limited data and require more analysis to confirm. Estimation of petroleum reserves. The estimation of petroleum reserves is based on geological and engineering analyses. The process involves the analysis of geological data such as rock properties, fluid properties, and structural features. The engineering analysis includes the evaluation of production performance and the design of production systems. There are several methods used to estimate petroleum reserves, including volumetric, material balance, and decline curve analysis. 1. Volumetric analysis is the most commonly used method and involves the calculation of the volume of oil and gas in the reservoir based on the size and shape of the reservoir. 2. Material balance analysis involves the analysis of the fluid flow in the reservoir and the calculation of the volume of oil and gas that can be extracted based on the balance of fluids in the reservoir. 3. Decline curve analysis involves the analysis of the production history of the reservoir to estimate the remaining reserves. In conclusion, petroleum reserves classification and estimation is an essential process for oil and gas companies. It helps them plan their exploration and production activities and make informed decisions. The process involves the analysis of geological and engineering data to estimate the amount of oil and gas in a particular reservoir. The estimation process uses several methods, including volumetric, material balance, and decline curve analysis. With this guide, you should have a basic understanding of petroleum reserves classification and estimation. Section 26. Understanding the different types of production forecasting and decline analysis techniques. Production forecasting and decline analysis techniques are essential tools for the oil and gas industry. These techniques help companies estimate the production of oil and gas over time and predict future production rates. In this guide, we will take a look at the different types of production forecasting and decline analysis techniques. Production forecasting is the process of estimating the production of oil and gas over time. The process involves analyzing various factors such as reservoir characteristics, fluid properties, production data, and economic factors. Decline analysis is a related process that involves the analysis of production data to predict future production rates. Types of production forecasting techniques. There are several types of production forecasting techniques, including analytical, numerical, and empirical methods. 1. Analytical methods involve the use of mathematical equations to predict the production of oil and gas. These methods are used to estimate the production of simple reservoirs with uniform properties. 2. Numerical methods involve the use of complex computer simulations to predict the production of oil and gas. These methods are used to estimate the production of complex reservoirs with varying properties. 3. Empirical methods involve the use of historical data to predict the production of oil and gas. These methods are used to estimate the production of mature fields with well-established production histories. Types of decline analysis techniques. There are several types of decline analysis techniques, including exponential, hyperbolic, and harmonic methods. 1. Exponential decline analysis involves the use of a simple exponential equation to predict the decline in production over time. This method is most effective for predicting the decline in production from a single well or a small group of wells. 2. Hyperbolic decline analysis involves the use of a more complex equation to predict the decline in production over time. This method is more effective for predicting the decline in production from larger groups of wells. 3. Harmonic decline analysis involves the use of a periodic function to predict the decline in production over time. This method is most effective for predicting the decline in production from fields with cyclic production patterns. In conclusion, production forecasting and decline analysis techniques are essential tools for the oil and gas industry. These techniques help companies estimate the production of oil and gas over time and predict future production rates. The production forecasting techniques include analytical, numerical, and empirical methods, while the decline analysis techniques include exponential, hyperbolic, and harmonic methods. With this guide, you should have a basic understanding of the different types of production forecasting and decline analysis techniques. Section 27. An overview of the role of sustainability and renewable energy in petroleum engineering. Sustainability and renewable energy have become increasingly important in the petroleum engineering industry. As the world seeks to reduce its reliance on fossil fuels, petroleum engineers are exploring new technologies and techniques to make oil and gas production more sustainable. In this article, we will provide an overview of the role of sustainability and renewable energy in petroleum engineering. Petroleum engineering is the field of engineering that deals with the exploration, extraction, and production of oil and gas. Traditionally, the industry has been associated with fossil fuels, which are non-renewable and contribute to climate change. However, in recent years, the industry has been moving towards more sustainable and renewable energy sources. The role of sustainability in petroleum engineering. Sustainability in petroleum engineering refers to the practice of minimizing the environmental impact of oil and gas production. This can be achieved through various methods, such as reducing greenhouse gas emissions, minimizing water usage, and improving waste management. One of the ways petroleum engineers are promoting sustainability is through the use of advanced technologies, such as carbon capture and storage, which help to reduce the amount of carbon dioxide released into the atmosphere. Another way petroleum engineers are promoting sustainability is by improving the efficiency of oil and gas production. This can be achieved through the use of enhanced oil recovery techniques, which can help to increase the amount of oil and gas that can be extracted from a single well. The role of renewable energy in petroleum engineering. Renewable energy sources, such as solar and wind power, have become increasingly popular in recent years. Petroleum engineers are exploring ways to integrate renewable energy sources into oil and gas production, such as using solar or wind power to power pumps and other equipment. Another way renewable energy is being used in the industry is through the production of biofuels. Biofuels are made from organic matter, such as plants, and can be used as an alternative to traditional fossil fuels. In conclusion, sustainability and renewable energy are becoming increasingly important in the petroleum engineering industry. Petroleum engineers are exploring new technologies and techniques to make oil and gas production more sustainable and reduce the industry's impact on the environment. Through the use of advanced technologies and renewable energy sources, the industry is moving towards a more sustainable future. By implementing these techniques, petroleum engineers can help to ensure that oil and gas production remains a vital part of the global energy mix while minimizing its impact on the environment. Section 28. A Guide to the Basics of Petroleum Product Quality Control and Specification. Petroleum products are widely used in many industries and for various applications. It is important to ensure that the quality of these products meets specific standards and specifications to ensure they are safe and effective to use. In this article, we will provide a guide to the basics of petroleum product quality control and specification. Petroleum products are refined from crude oil and are used in various industries, including transportation, manufacturing, and energy production. These products include gasoline, diesel, jet fuel, lubricants, and others. To ensure the safety and effectiveness of these products, they must meet specific quality standards and specifications. Product quality control. Quality control in the petroleum industry refers to the processes used to ensure that petroleum products meet specific quality standards and specifications. Quality control processes can vary depending on the type of product and its intended use, but they generally include testing and analysis of various product characteristics, such as physical and chemical properties. Some common quality control tests for petroleum products include octane rating, used to measure the performance of gasoline in engines; cetane rating, used to measure the performance of diesel fuel in engines; flash point, the lowest temperature at which a liquid gives off enough vapor to ignite in the presence of an ignition source; viscosity, a measure of a fluid's resistance to flow; product specification. Product specification in the petroleum industry refers to the specific standards and requirements that must be met by a product. These specifications are typically set by industry organizations, government agencies, and manufacturers. Product specifications can vary depending on the intended use of the product. For example, aviation fuel must meet specific standards set by the International Air Transport Association (ITA) to ensure safe and reliable performance in aircraft. Other specifications may be based on environmental concerns, such as the amount of sulfur allowed in diesel fuel. In conclusion, ensuring the quality and specification of petroleum products is crucial to their safe and effective use in various industries. Quality control processes, such as testing and analysis, can help ensure that products meet specific standards and specifications. Product specifications are set by industry organizations, government agencies, and manufacturers to ensure that products are safe and effective for their intended use. By understanding the basics of product quality control and specification, companies and consumers can make informed decisions about the petroleum products they use. Section 29. Understanding the different types of well intervention and workover techniques. Oil and gas wells require maintenance to keep them producing at optimal levels. The maintenance of wells is achieved through well intervention and workover techniques. In this article, we will explore the different types of well intervention and workover techniques used in the oil and gas industry. Oil and gas wells are subject to decline in production over time. This decline can be caused by various factors such as reduced reservoir pressure, wellbore damage, or other factors. To maintain or improve production levels, well intervention and workover techniques are used. Types of well intervention techniques. Well intervention techniques are used to restore or enhance the productivity of the well. The most common well intervention techniques are 1. Coiled tubing intervention. This is a method where a continuous length of tubing is inserted into the well bore to deliver fluids or carry out downhole operations. 2. Snubbing. A technique where a pipe is inserted into the well bore using a hydraulic unit. 3. Slick line intervention. A method where a slick line is used to deliver tools or perform wellbore operations. Types of workover techniques. Workover techniques are used to repair or replace downhole equipment. The most common workover techniques are 1. Pulling and replacing tubing. This technique involves removing and replacing tubing, and sometimes other downhole equipment. 2. Fishing. A method used to retrieve lost tools or other objects from the wellbore. 3. Reperforation, a technique that involves creating new perforations in the wellbore to increase production. In conclusion, well intervention and workover techniques are used in the oil and gas industry to restore or enhance the productivity of the well. The different techniques used depend on the specific problem with the well and the desired outcome. Coiled tubing intervention, snubbing, slick line intervention, pulling and replacing tubing, fishing, and reperforation are some of the most common well intervention and workover techniques used in the industry. Section 30. Understanding the different types of petroleum asset management and portfolio optimization techniques. In the petroleum industry, asset management and portfolio optimization are critical to the success of oil and gas companies. This involves managing the entire life cycle of oil and gas assets, including exploration, development, production, and abandonment. Effective management of assets requires a good understanding of the different types of assets, their value, and how to optimize their performance. In this article, we will discuss the various types of petroleum asset management and portfolio optimization techniques. Asset management. Asset management involves the effective management of oil and gas assets to optimize their value. There are various types of assets, such as exploration assets, development assets, production assets, and abandonment assets. Asset management includes managing the risk associated with each type of asset and implementing strategies to minimize those risks. Asset management also involves managing costs and maximizing returns on investment. Portfolio optimization. Portfolio optimization involves managing a group of oil and gas assets to maximize their value. This involves assessing the risk and returns associated with each asset and determining the optimal mix of assets to achieve the desired portfolio performance. Portfolio optimization involves analyzing the performance of each asset and assessing how it contributes to the overall portfolio performance. Types of petroleum asset management and portfolio optimization techniques. There are several techniques that are used for petroleum asset management and portfolio optimization. Some of these techniques are: A. Risk management. Risk management is critical for effective asset management and portfolio optimization. It involves assessing the risks associated with each asset and implementing strategies to minimize those risks. Risk management techniques include risk assessment, risk identification, risk mitigation, and risk monitoring. B. Performance analysis. Performance analysis is critical for effective asset management and portfolio optimization. It involves assessing the performance of each asset and analyzing how it contributes to the overall portfolio performance. Performance analysis techniques include financial analysis, operational analysis, and production analysis. C. Portfolio modeling. Portfolio modeling involves developing models to simulate the performance of a portfolio of oil and gas assets. This technique involves assessing the risk and returns associated with each asset and determining the optimal mix of assets to achieve the desired portfolio performance. D. Asset valuation. Asset valuation involves assessing the value of oil and gas assets. This technique involves assessing the market value of each asset and assessing the costs and returns associated with each asset. In the petroleum industry, effective asset management and portfolio optimization are critical to the success of oil and gas companies. This involves managing the entire life cycle of oil and gas assets and optimizing their performance to maximize returns on investment. There are various types of petroleum asset management and portfolio optimization techniques, including risk management, performance analysis, portfolio modeling, and asset valuation. By understanding these techniques, oil and gas companies can effectively manage their assets and optimize their portfolio performance. Thank you for bearing with us. Hopefully you would have learned a lot about petroleum engineering.